Hi everyone. In this video we're going to use a photoresistor and an analog read command that will display values on the serial monitor based on the LED intensity. Okay, so the first thing we need is a photoresistor. You have one of these in your kit. And put it down on breadboard. Okay, now we're going to need two resistors. So and I'm going to need to rotate those sideways because we're going to put those resistors in parallel. So this little tool here will allow me to do that. Get it back in the right spot here. Okay. Same thing with this. I'm going to rotate it. Okay, now I want to use the same values as you have in your kit. So what we'll need to do is to use two 10 kilo ohm resistors. You have those in your kit, so I'm going to change that to 10. And same with this. Now when you take two 10 kilo ohm resistors and connect them in parallel, and parallel means essentially that you have to connect the terminals together. So you see terminal 2, terminal 1 are all in the same rows, so they are connected together along with this terminal of the photoresistor. And then the same thing on this side, there's terminal 1, terminal 2, they are connected together. So they're in parallel, and when you have two equal value resistors in parallel, the total resistance is half the value of the individual resistors. So what we have is 5 kilo ohms there for the total resistance. Okay, now we're going to connect a wire from here to the ground. Okay, and on this terminal of the photoresistor, that's got to go to 5 volts. Like so. Okay, now we're going to use one of these analog ports. In the past, we've only used digital ports, but the analog port will be useful here. And I'm going to take a wire and connect from this side of the resistor to any one of those analog ports. I'll use A0. Okay, now an analog port has the ability to sense any voltage between 0 and 5, as opposed to a digital port, which can sense only 0 and 5 volts. But the analog port can sense any voltage in between. Furthermore, the analog read, when you read that port, it's going to return a value anywhere from 0 to 1023. That's going to be proportional to the voltage at the analog port. So if there was 0 volts, it would return a value of 0. If there was 5 volts, it would return a full 1023. If there was 2.5 volts, it would be whatever half of 1023 is, 512 roughly volts. Okay, so that's all there is to wiring this up. let's get to the code. Okay, so since we're going to be using the serial monitor, we've got to do a serial begin 9600. Okay, now what I want to do is I'm going to read the value at the port, and I'm going to store it in a variable. So it's going to be an integer. So I'll type int and reading equals analog read and then A0. One thing I wanted to mention is that since this is an analog port, you don't have to configure it. So you can just use it and it will read an analog value. Okay, now I just want to take that reading now and display it on the serial monitor. So it's going to be serial.println reading. Okay, so let's try it out. Okay, now get serial monitor. Okay, you can see there's a value of 28 there. Now the way that you can change the intensity of the light that is shining on the photoresistor is if you just click on it. Notice that a little tool opens up here, and as I drag this across, you can see that basically what that's doing is it's kind of a virtual increase in the amount of light on the photoresistor. And you can see this value increasing. So it's 404. As I make it even brighter, it goes up to 692 and 891 and 929. I'm not sure why it doesn't go all the way up to 1023. It probably should, but doesn't seem to. But okay, so anyway, that's how you do it. So I want you to build this circuit and try this out. Photoresistor is the device that looks very much like this little picture. It's got those kind of squiggly lines on the top. And of course, you'll have to change the light intensity of the room to test this, or you could just take your hand and shade the photoresistor so it gets less light and watch the value on the serial monitor.